Hello, 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 hello. Thank you for coming for the webinar. Please write me in the chat that you can hear me well, and after that I will start the presentation. While we were preparing for the webinar, I was reading the chat, and there are guys even from New Zealand. You are heroes, I think. Okay, hello everyone, nice to see all of you here. We will wait a little bit while you... Okay, we can hear you well, someone is telling me, fine. So, while everyone is... Yeah, the guy's telling me that all is good. Okay, sounds good. Fine, guys, thank you. So, today we have a webinar which is dedicated to offline robot programming. Thank you all for coming. I hope this will be useful for you. I must say that in our program today we have an introduction to offline robot programming. So maybe I think there are people definitely who are very experienced in robot programming. Maybe this will be not so helpful for you, but I hope you will also find something interesting because I will show something which we have never shown before today. Okay, so please stay until the end and we can start. Yeah, guys from Australia and from Taiwan, yeah, hello, hello. Very nice to see you here, especially taking into account your time zone difference. Okay, so I will switch to the presentation now. Fine. So, offline robot programming and ENCY Robot as an ultimate offline robot programming tool. Today we will have an overview of the capabilities, and for better understanding, I will try to explain you what are the main challenges which we are addressing with ENCY Robot software. Webinar duration will be 1 hour. I will have a short introduction, and the main part will be dedicated to live demonstration of the products not one, actually two. So I think it will be also interesting for you. And so instead of just watching the presentation and slides, you will be enjoying the live demonstration on the screen, which I will be doing for you. Before we start, let's have a little discussion. So maybe you can write in the chat right now, what are the main challenges in robot programming that you or your customers, if you are a robot integrator, are facing? Probably while you are writing it in the chat, while you're writing it in the chat, the challenges, probably I will speak about them. So of course, the approach which was used for robot programming during many years was based on the manual robot programming with the teach pendant. Obviously, this has drawbacks and strengths, and with this like teach pendant programming, I think the main challenge is the impossibility to program a robot for complex toolpaths. So please write your options in the chat. I will wait for answers for you. Let's have some conversation today. Not only me speaking, but also you participate. So what are the main challenges in robot programming? Tell me. Maybe you have customers, maybe you have experienced yourself some situation when you were not able to program your robot. What was the obstacle? Okay, I think YouTube has quite a big latency, so I can see the chat with some kind of delay. Okay, but anyway, while you're writing, I will continue then. Oh, wait a second. Deburring, quite a challenge, especially as parts dimensions can vary from part to part. Oh, yes. So the parts are different a little bit, for example. So, while you're writing, I will continue and tell what challenges are we addressing with our software. So, as I already said, the toolpaths for complex movements is a big challenge. Yeah, for example, for polishing or for additive manufacturing, it's not possible to make any programming of robot with teach pendant with manual programming. Second, all robotic cells are unique, which means you cannot use the same program for different robotic cells. Okay, for example, you have some robotic cells, maybe they're even very similar, but still they can have some elements which you should take into account when you make collision detection. Okay, so you cannot run one program on different robotic cells. Kinematics management is another big challenge. As we know, robots themselves have 6 axes, and then there is very often some additional kinematics, additional axes, which are external for robot, and the robotic cell can encounter 7, 8, 10, 15 axes. So it's quite complicated to manage the kinematics of the robotic cell. Yeah, collision avoidance, I already mentioned it. And there is also a situation that with the robots, we can use robots for various applications like welding, milling, painting, additive, and so on. And you need a specific tools which are taking into account these technologies when you are programming. It's not enough only to program points, or the tool center points. It's also important to program the end effector, the equipment which you have on the flange of the robot. Trajectories correction and adjustment takes much time. Oh yes, so what's ENCY Robot then? Okay, actually ENCY Robot is the software which is addressing all these challenges and making robot programming very fast and very easy in many cases. Okay, we've been in this area since 2008. Okay, so we have like 15 years experience of robot programming software, and there are plenty of customers which are using our software for offline robot programming. So ENCY Robot is a true all-in-one robot programming software, which means that it includes toolpath calculation, robot kinematics management, simulation and control program verification, and post-processing and output ready-to-use program for robot. Okay, you guys are writing the challenges. I will interrupt for a second and read, okay, what you are writing, and maybe I think there is something interesting, definitely. So the biggest problem is when robot movement is non-linear. Yeah, something similar to CNC. The complex toolpaths. Interpolation and complex curves are hard to teach via teach pendant. Exactly what I'm talking about. Okay. So, as a solution for all these challenges, we offer a complete offline robot programming platform, which is ENCY Robot. Okay. I must say one thing about the interface. Okay. In our area, the software is made by engineers for engineers. And it turned out that engineers are not thinking very much about user experience and user friendliness. That's why robot programming software usually looks quite ugly, I would say, and more importantly, the workflow is very complicated. Okay, this is combined with robot itself programming process, which is not easy, makes like hard to program robot plus hard to use software makes robot programming a real pain, and not only pain but also involves very long learning curve. Okay, and not so time effective as it is requested by the market today. So we are on another side of this situation and this approach. We have always been focused on creating as user-friendly interface as possible, and for robot programming especially. So we put a lot of effort into our interface development to make it visual, interactive, intuitive, and really easy to use and easy to learn. Okay, So this is one of the priorities, high priorities, which we always keep in mind and focus while we're developing our software. So you will see the interface in action in a couple of minutes. Okay, some other challenges. Okay, there are some questions which I will answer at the end of the webinar. Thank you for the questions. By the way, yes, you can write your questions while I'm speaking. At the end, I will read the questions and try to answer all of them. Okay, so what are the capabilities of the technologies or applications we are focusing on? As I already mentioned, there is a very big variety of applications for which robots can be used. And of course, we are focusing on applications with complex toolpaths, which cannot be programmed by hand. First of all, and for many years, it was robot milling. Despite the maybe you can say, okay, robot is not suiting for milling, and it is true for hard materials. But for light materials, there are plenty of applications, starting from foam machining for different decorations, like theater decorations, cinema decorations, like you see on the screen, boats production, and many other situations when robots for light materials can substitute the CNC machine. Okay, and they are much more cost-effective than CNC machines in this particular situation. So robot milling is our #1 focus. And it was like this for all the years starting from 2008. What's new happening here is that we are now developing additive manufacturing capabilities, because robots, as we can see, according to the demand from the market, we can see that robots are suiting very well for additive manufacturing. So we are pushing and we are investing into development of additive manufacturing algorithms and additive manufacturing programming with our software. Next, big topic, robot welding. What we can say about welding? Yeah, for many years, welding was like a default option for welding programming was by hand. Okay, and in many cases, it is still the best approach. But the situation is changing, and we can see that more and more customers are using or want to use software as standard for robot welding. I think you will like it. Another area which can be considered as a separate area, as a sculpture, stone machining. This includes extremely complicated toolpaths. I mean, 5-axis finishing over mesh model toolpaths. Okay, this is not an easy area for toolpath calculation, of course, and we can offer here a complete solution. Okay, I will show you also. Pick and place. Pick and place is usually, of course, programmed by hand, but if you have a project where you have assembly and pick and place is combined with welding, then you should program pick and place with the cadcam software, which we also provide you. And two, like other applications which are spray painting, we have a special painting simulation algorithm which is showing you the thickness of the layer for spraying and material dispensing. Okay, it can be not only spraying but some other dispensing. And for polishing, I will also show you today something interesting which you will like. So another area and topic we must discuss is that, as it was mentioned at the beginning of the presentation, one of the challenges is that you always have unique robotic cell. So unlike CNC machines, when you have one CNC for many, like and they are very similar or identical, robotic cells are in most cases unique and they are built for a particular customer. So in order to program a robotic cell properly in the offline mode or like in the software, in the standalone software, you need to have a digital twin of this robotic cell. And for this purpose, we offer a product which is called MachineMaker, which is a zero-code digital twin builder for robotic cells, CNC machines, which is not the topic today, but for robotic cells is a definitely topic today. So you can use MachineMaker to build whatever robotic cell you have or your customer has in order to program it with ENCY Robot. So MachineMaker is featuring not only like a builder, but also it has components library. It's available online. We are always working on putting more and more components into the library, but it's also possible to build your own components with MachineMaker. So if you don't find any component in the MachineMaker, it may be a robot, for example, or maybe an end effector or positioner or whatever, you can build this component with MachineMaker, no problem, okay? And the main like application area for MachineMaker is to build virtual robotic cells or digital twins. That's obvious. And last but not the least, that MachineMaker is providing you user-friendly input of TCP and base calibration data. This is a completely different, like separate topic. I think if there will be a demand, we will make a separate webinar which is dedicated for TCP and base calibration, because we have an app which is called Robot Calibration as an assistant for double spike calibration method. So unfortunately, during this webinar, I don't have a possibility to show you all this process because it takes quite a lot of time to demonstrate. But if you want, we will make a separate webinar. Write it in the chat if you need it. Okay. So let's start having a preview of the products, and let's start a live demo. So first, this is the interface. It's very easy to use. I will use online library. You can find it here. And let's maybe take a look at what we have already here. For example, we have ready to use robotic cells. For example, this one, I can just open and adjust it on my own taste. Okay, so all the usage of MachineMaker is very intuitive and user-friendly, so you can just drag and drop objects, okay, or you can of course manually move objects like this. What's important here? Okay, on the left you have all the kinematics defined here of your robotic cell. So let's say I would like to add some new component. No problem. I will just find some, let's say, we would like to add some, for example, whatever fence, okay? I just put it in my robotic cell and put it into correct position which I want. So this is very, very easy to use and user-friendly tool. And of course, we can move all the axes here, so it's not a 3D model, it's a 3D model which is actually combined with kinematics model, and all the objects here are already moving. You can check it, okay, like this. What's also important in MachineMaker is that we have here settings which are connected with like we call it assembly settings, which are connected with behavior of different like coordinate systems, access during programming. For example, robot support arcs, yes or no, you can enable or disable it here. Does it support spatial arcs, yes or no, and so on. Also, there is a section for definition of leads or approaches and retracts. You can define your own approach and retract rules, which will be used by default. You can add your own ones. So this is not only, so you understand that this is not only tool which is used to put the objects in the right positions, but also a tool to prepare your full digital twin, which is now available for programming with ENCY Robot. What's important to say? And every component with double click, okay, here is the kinematics, so I can adjust the kinematics of any component. Okay, I can change dimensions, I can do whatever is required. So all the measurements are editable, so you can change whatever you want. So it's a powerful tool. Be careful. It's quite easy to destroy something, but it's easy to use, so I think you will not experience many problems with MachineMaker. It's really easy to use. And I can see, we have seen many times that customers who just downloaded a trial version from the website have managed to learn how to build their own robotic cell, and during their trial period they already have their robotic cell, so they have like testing the software. They have already tested the software not on some abstract robotic cell but on exact their robotic cell, so they can do it from scratch during maybe several days. So I think you also can do it. The last thing now I would like to show you is that here you can also input TCP calibration data. Here you can see the QR code, which is made for automatic data transfer from the app, which you can download here. Please try it. It's a really nice application, which makes life easier, so you don't have to manually input 6 numbers, maybe sometimes even more. Like here you have like 10 numbers, 10 digits. So all this data is transferred automatically from the app, and the app is used to recognize the numbers from the robot controller. So you just take a picture and transfer these numbers into MachineMaker. Okay, and here you can also see that we have support of different types of robots. Some of them work based on quaternions, some of them work based on Euler angles, so everything is supported. And in case we have some specific scenario or specific robot or whatever, which is for some reason was never requested by our customers, you can always send us a request, and if something is not supported, it's no big deal to make support of some specific robot or whatever. So feel free, if you don't find your Euler angle, for example, combination, feel free to send us a support request. We will put this into MachineMaker and also ENCY Robot. So the last thing I would like to show you concerning MachineMaker, on our website encycam.com you can find a component library, and all the components are available. So you can check what we have in our component library and check the specifications, and here you can download the digital twin of the specific robot, but actually you don't need it because you have the same library here. So if you have it online on the website, you have it here in MachineMaker, so you don't have to worry about downloading and loading something. Just open MachineMaker and use the same online library which you have on the website. Fine. Yeah, concerning the trial version, I have the question. I will answer it right now. Yes, everything is available in the trial version. MachineMaker and all the applications, all the technologies in ENCY Robot are also available for trial. So the trial has the only limitation that it has 30 days limitation, and you cannot run trial license twice on one PC. Okay, so don't try it. Fine. So next topic and next big section which I would like to cover is the ENCY Robot itself. So let's take a look at the project, and on this example, what do we have here? Let me show you. On this example, I would like to show you some really nice kinematic management and collision avoidance features which we have. But first, I would like to mention, for those of you who have never contacted us before, I would like to say that for robot programming, we have the full range of toolpath calculation algorithms for milling, for welding, for additive manufacturing, for probing also, and so on. So a lot of technologies are available, so you can program almost any robot movement, and also, which is also very important, an end effector, because sometimes you have a simple end effector like this, which has only on and off commands, maybe like spindle speed command, that's it. But in many cases you have a really complex end effector, which is like using some used, for example, for additive manufacturing, so you can output the commands which will be controlling also the end effector equipment on your robot. Okay, so this is a milling project. Let's take a look at the simulation first. So it consists of 2 roughing operations and 1 finishing operation. Looks quite simple, but if we take a look at this robotic cell, how many axes does it have? So robot has 6 axes itself, then we have a rail which is 7, and we have a 2-axis positioner. All in all we have 9 axes in this robotic cell, which is quite a lot. And the main challenge concerning robot programming, comparing to CNC machines, and the main difference is the kinematics management, because even if we speak about 5-axis toolpath, it only has it's only enough to have 5 axes to make this toolpath, I mean to execute this toolpath. And what to do with other axes? Okay, you have like at least 6. So in this case, when you have additional axes, you have to define some algorithm which will be controlling the redundant axis behavior during toolpath execution, which is not directly connected to the toolpath itself. This is quite a maybe look like quite a complex concept, yes, but when you look at it in a visual way, you will understand very fast. So, for example, let's take a look. Here we have 2 operations which are basically only 3 axes. So even we don't even need 6 axes, and of course we don't need 9 axes to make this toolpath execution. And at the same time, we can do the same toolpath in many ways. So the robot can be configured in different positions and different configurations, and still execute the same toolpath. In order to control this behavior of additional axes, we have several tools. For example, this one. Okay, so you can define, this one is simple. You can define like the magnet point, which will be used to control the position of 5th axis of the tool during toolpath execution. Okay, so and you can say, okay, I have the magnet here, so the toolpath is like the 5th axis is controlled in a way so that it is aligned with this vector. Okay, this is quite an easy tool, but still very powerful. In many cases it's enough only to have this, but there is also an option which you can use, like a in cases you cannot use only a simple magnet, so you need to change this behavior during toolpath execution. And for this scenario we have a robot axis map. It may look a little bit overwhelming, but once you understand the idea, it will be very easy to you to use it, and it's very visual and very intuitive. So what do we have here on this graph? So all the colored areas are bad areas. Okay, along x-axis we have the toolpath. Along y-axis we have the angle of the 6th axis of the tool. So, and this green line is the trajectory of the 6th axis of the tool, which you can define throughout the toolpath execution. It's very easy to understand when you look at the same time at the simulation, at the graphic window and on the robot axis map, and move it like this. So, in every point I can change the position of the tool axis, of the tool around the tool axis, and you can understand, of course, that the result of these changes will only be visible on the kinematics of the robot. The toolpath itself is not changing. So with this tool, you are not influencing any like toolpath itself. You are changing the behavior or the kinematics of the robot throughout the toolpath execution. And visually, the task is very simple. You need to go from left to right without crossing any colored area. That's it. Very visual tool. And these gray areas are actually the links, the transitions. They are a part of the toolpath. So they are shown for you to understand that in these areas you have non-cutting movements for your information. So you can cross them, of course, inevitably. It's okay. So with this robot axis map, you have a full control over your redundant axis during toolpath execution. And you can change not only sixth axis of the tool, but also you can change the behavior of all the redundant axes, all the additional axes which you have in your robotic cell. Okay. Next, I must mention that it may be, if you look at this for the first time, it may be very, very confusing for you. So please take a chance to go to our YouTube channel and learn the lesson which is called ENCY Robot Get Started. These 4 videos are explaining all the basic robot kinematics tools, how they work and how to use them. Okay, so just on the website you can click Learn ENCY Robot Get Started and it will open for you the playlist on the YouTube. That's it. So the robot axis map is explained there very well. So please take a look. Okay, meanwhile I will go to the next topic here, and this topic is actually collision detection. Let's say I will open the project from scratch so that we don't have to wait until the toolpath is recalculated. So let's say we have this kind of process. First we make a roughing water line from one side, then we have a roughing water line from second side, and we need to make a transition between these positions. Okay, you can already see that here on approach I have collision avoidance enabled. I will disable it for a moment. And let's see what happens. So, in order to see, we are switching to simulation, and I will just like quickly go through the simulation of this roughing operation, which you can also enjoy. I believe it works very fast and very detailed. And by the way, I will enable stop on errors so we can catch the exact collision situation and take a look at it. Yeah, by the way, on the left, for those of you who can see our product for the first time, on the left you can see the program actually. Okay, this is the program which was calculated in the machining tab. In the simulation you can simulate the program which you have just calculated. So this is program already usable for this particular robotic cell, so you don't have to use some other software to transform your toolpaths for robots. Okay, ENCY Robot is a complete solution, so you don't have to use any other software to adapt your toolpaths for the robots. So we have a situation. Okay, this is definitely a collision. The collision avoidance algorithm detected the collision and tell us, okay, we have a problem here. So how can we solve this situation? There are many ways of how we can do it, but the most easy and the most effective is to use automatic collision avoidance. Okay, so I will just avoid collisions and recalculate the toolpath. We'll have to wait a little bit for toolpath calculation, sorry. So basically what this collision avoidance algorithm is doing is that it detects the collision during the transition, and it's looking for the new, detects for the new points and adds new points to this transition so that it becomes collision free. What's important to know about collision avoidance? Please do not use it everywhere, because it will inevitably don't use it without necessity, because it will inevitably increase your toolpath calculation time. In order to use it in the most time-effective way, just enable it in those transitions where you have collisions. For example, in this operation, we have collision at the approach, but we don't have any collision at the return. So we don't need collision avoidance at the return, we need it only for approach. So I will reset, here. I will reset the status, and now let's take a look at this approach. You can see now it's different. So instead of just one movement, there are now several points, and it gradually moves and avoiding collision with the workpiece. Let's take a look at slow speed how it looks now. Yeah, maybe it may seem to you that here the distance is too small, so you can put this safe distance, put here a bigger number, and you will get bigger clearance between your objects. But what's important to say that this collision avoidance algorithm is taking into account all the objects within the work area, including the current state of the workpiece. It's very important, okay, because your workpiece may change during toolpath execution, and collision avoidance should take into account current workpiece state. So exactly what we can see on the screen, exactly this shape is taken into account for collision avoidance. Okay, and now we can run the second roughing part. Very fast, and after that I will show you the last thing in this project, and we will switch to the next one. So after the roughing is done, the next stage of this project is actually the finishing. Okay, the finishing is a completely different situation, because it's a 5-axis toolpath which is including rotation of the table and also inclination of the tool, so that it's making machining of this shape, which is very complex for a CAM software, and we still have no collisions. Okay. By the way, you can always control your robot movement with your control panel. You can see all the 9 axes here, coordinates. So of course now we have 7-axis toolpath. Our E1 and E3 are not involved in this situation, in this toolpath execution, because we don't need it simply, but all other axes are working simultaneously. So you can control it in the machine control panel, which I believe is quite spectacular. So what do we have here for kinematic management? Due to the fact that this toolpath is 5-axis, and we want to optimize the execution of the toolpath so that the robot is not going around the workpiece, but as much as it's possible it stays on one side, from approaching the workpiece from one side, and all this round movement is done via rotary table. So we engage rotary table rotation here, and we must define this rotary table vector. This blue vector is defining from which direction will the tool approach the workpiece, the table. So you can change this vector, so it's set to +x, you can change it to whatever, you can put custom vector, and you have a positioning mode, which is also a variation, a flexibility, which can be very helpful in different situations. So you can position the tool axis, tooltip point, or mixed. So this, try it at home, I advise you. And you will see the different behavior of the robot during toolpath execution. Okay, and actually, if we take a look at the simulation, so let's make it like this. So this is the workpiece which we have after our roughing operations, and if we run now the simulation of this finishing operation, we will see. Let's move it a little bit faster. Okay, so we can see that the tool contact point, this one, okay, the white one, is aligned with the x-axis. So it is now moving according to the rule which we have defined in the rotary table axis parameter. So all these tools are made to define some additional limitations or laws or rules for redundant access. This is specific for robots. Sometimes CNC machines also have this necessity, but mostly this is done for robots. Okay, very nice to look at, but we should switch. So, from the first point of view, this is a really simple project. Okay, we have just a big cylinder and we need to make these little holes in it so that so that we have only one operation for drilling, and also here we have a rotary table. Okay, and it might seem easy until you understand that you have to manage the approach and the retract in this situation when you have the very tight area inside this tube and the very big robot which must fit there and do not crash during this movement. And this is a very nice example of how collision avoidance is working. So first I will turn it off and we will see what happens. All seems okay, but when we start simulation, okay, we have a problem here. The problem is not only that we have the collision, but also we have a 7-axis movement simultaneous. And I think you don't want to program this by hand in no scenario. Of course, you can move it like one by one, but it will be not time effective. So in this situation, the perfect solution is a collision avoidance algorithm. So let's engage it and calculate the toolpath again. So now we are, like you see at the bottom, we are eliminating the collisions. And after that, in our approach, we have several movements you see now on the screen, which are helping us to avoid the collision. And the robot fits in a very tight area. You can control in simulation with a very high precision how the robot is moving inside this workpiece and making the machining. This is the example how you can save huge amount of time just with a couple of mouse clicks when you need to use your robot for within a really tight areas, and you need to like maximize your robot potential and reach really hard to reach points in your or areas in your project. So that's it. Okay. Now something new which we have not shown before, and this is a new feature for ENCY, and this is weaving. Weaving for welding first. So before that, like for quite a lot of time, many years, we we've had our welding robot operations in our software. But now we have implemented with this weaving feature, so you can add different weaving patterns in your toolpath, and they are simulated, so the collision detection is working for them also. And in these tight areas, when you have this nozzle of your welding torch, and you can control so that it is not touching your workpiece in no scenario. Let's take a look at how the simulation works. So I think it's quite intuitive and visual. You can understand anything. Also, here the additional access is involved into machining to optimize robot movements. Yeah, in this project we also have touch sense and different weaving patterns. We can also see the weaving itself. Let me show you. So the touch sense is finished. Yeah. So the weaving toolpath itself can be observed. Let me just make it like this. I will put some transparency because it's inside of the part, so you cannot see it when you have. You should either disable your part visibility or enable transparency so that you can see from the inside. Okay, we have double 8 here. So let's have a quick review of what other weaving options do we have. So here we have triangle, trapezoid, spiral. Let me show you the pictures also. So triangle, trapezoid, spiral, double 8, curvy, crescent, and you have the parameters to define this geometry. And also, what is in our opinion important for welding is that you have an option how to output the ENCY code, I mean the control program. Either you can export ENCY code longhand or in a cycle. I believe for welding you will be using cycles because the welding system itself has cycles and it's better to use these cycles. But when you're using these cycles, you still have the possibility to simulate the welding with weaving, which is, I think, very important. And also define here the parameters, and then in post-processor you will use these parameters for definition of the welding weaving cycle. Next. Yes, another application for weaving is polishing. So, polishing is a different animal, while welding can also have like very complex shape of the surface, but for weaving, for polishing, you will have a really complex surface shape, I think, always. Let me also turn on transparency so that we have the toolpath visibility. And what's important and what's the difference between weaving for welding and for polishing is that for polishing we have this feature which is projection of the weaving onto the surface. So all these weaving patterns are now projected and they are aligned with the surface in every point, so you have a really quality toolpath for polishing with this. Let's take a look at simulation really fast. I will disable machine collisions because it's polishing toolpath, so the tool is inevitably, you see, it's inevitably like trying to go to the part if you speak in terms of material removal, but we understand, of course, that this is a soft tool and we don't need this collision detection. So this is weaving. So you can see that the robot movement is very complex, but it's programmed really easy, so you don't have to do anything manually. You just define your weaving pattern, geometry, and you have the result. So don't worry about this red collision detection. I just didn't turn it off, okay, for this demonstration. And in this particular scenario, we can see that, yeah, the part itself is very complex. It's some kind of like blade, or what is it, I don't know, but it's very complex shape of the surface, and all the weaving pattern is ideally projected onto the part so that your toolpath is correct for this particular part, so you will get a good quality for this particular case. Okay. To me, looks very nice. Yeah, all the robot movements. We can also engage the machine control panel, so we understand what are the coordinates. Okay, we can look at this forever, but we have limited time, so let's switch to the next thing. And this is additive, non-planar additive functionality. This is also new. So let's take a look quickly at the project. I would say that we are still working on development of this algorithm and this slicer, but it's already here. You can use it, and it's really powerful. So what do we have here is let me turn on the so we want to create or to build with additive technology this complex shape on this non-linear, non-planar surface. So non-planar slicing is generating non-planar levels and infills. So very easy to understand when we look at the simulation. Another interesting thing I must mention here is that we can also define the kinematics of the robotic cell so that the tool axis is always vertical because of the requirements of the additive manufacturing process, because due to gravity issue which we have on Earth, in many cases we have to preserve the orientation of the tool axis for additive manufacturing strictly vertical. And in this case, we have this two-axis positioner, which helps us to preserve the tool orientation vertical. While we are looking at the simulation, I would like to say that all the algorithms and all the toolpaths and all the simulation algorithms, everything is our proprietary algorithms. We don't use any third-party algorithms here, so everything is developed by us, and we believe that this is a correct approach, because only having control over all source code of the software, we can provide a really good solution and maintain the quality. So all the projects which I'm showing you, and even more of them, are available in the project library, which is online project library for different purposes. And you can install the trial version of ENCY Robot today, and let me show you, and open the project library. Very easy. Sorry, my PC is struggling with all this streaming software sometimes. Okay, so you have this project library. It's available for trial users also, and you can check all the projects I was showing you today. Let me make it a little bit smaller. Okay, if you choose recommended here and provided by ENCY software, like this, you have this welding project, another welding project which is more interesting, the Batman project, and other projects which I was showing you today. So please feel free to explore these projects yourself. You can just click open project, it will download the project and open in your ENCY Robot instance within a couple of seconds. And also, if you want to explore a bigger amount of projects, you can switch to all projects. And here we have, let me check how many of them. Here we have 400 different projects, so you can explore yourself. And you have here we have some filtering possibilities. So feel free to install the trial version of ENCY Robot and check and explore all the demonstration projects which we have in the project library. It's available for you if you have a trial license. Okay. Last thing I would like to say for now about the additive manufacturing is that, of course, for us, it makes no difference what kind of operation do we have. And I mean, in one project, we can have both additive and material removal operations. So in one project, you can create additive and finishing with some milling tool, for example, for one part, and you need only one software for this. I would like to say a couple of words about what else do we offer now. So ENCY Robot is okay, but what else do we have? You may ask. So, and I would like to answer this question. So, of course, besides robot programming software, which is one of the our main products, we have a cadcam software for CNC machines programming also, which is called ENCY. So if you have if your machine shop has robots and CNC machines, you can use one software to program them all, and it's a huge benefit, we believe. And actually, I must say that our robot programming software is grown up from a cadcam software, and cadcam software is the area which we are working in for 30 years. And we have a really outstanding product. I think you understand it. So fine. Next, we have a robot programming software, ENCY Robot, which is made specifically for robots and empowered by robot kinematics management tools, which we don't have in the cadcam software for CNC machines. So this is a specific tool, but it has all the toolpath calculation power on board from the cadcam software for CNC machines. Next, we offer an ENCY tuner, which is a shop floor G-code simulation software and editor. This software ENCY tuner is natively integrated and has native compatibility between itself and ENCY Robot. So you can import ENCY Robot projects or ENCY projects in ENCY tuner and have the simulation by your on the shop floor near your machine or robot. This is highly demanded by a bigger, or let's say mid-size companies, which have separate like cadcam office and shop floor, and which have several machines and robots. So all in all, I would like to say that we offer not a traditional cadcam software, but we are offering a cadcam ecosystem for a modern machine shop, which is involving not only toolpath calculation, simulation, post-processing, verification, but also transferring ENCY code from cadcam office to machine and robot operators. And all this ecosystem is connected with the cloud collaboration tool, which is a completely different topic. I would just like mention it today. I think we will make a separate webinar dedicated to cloud collaboration platform. But to have the rough understanding of the whole picture, I'm telling it about it to you today. So. For now, this is it. I have run out of time. So thank you for attention. Now I will answer your questions. After the webinar, you can visit our website, which is encycam.com, and download the trial version, which is available for free after you register on the website. And you can also set a get a quote request, so our sales team will contact you and discuss your project and your requests. Okay, that's it for today. Let's now switch to questions and answers section. I will read the chat which I have in front of me. Let me do it like this. Okay, fine. So quite a lot of messages for today. Thank you all for this activity. I hope you like the webinar. Please now write what particular topics do you need or are you interested in, so that we can make a separate webinar. For example, for if you want to know more about robot milling or welding or polishing or additive manufacturing, and you would like to have a more detailed webinar about these applications, please write it into the chat right now, and we will see the demand, and in case we have people interested, we will make these separate webinars. And meanwhile, please also, before I start answering your questions, please also click subscribe button on our YouTube channel. It's a young YouTube channel. Please help us to promote. So subscribe to our YouTube channel. Okay, so let me check the questions. Is there a possibility even during the trial version? Yeah, this was a question about the MachineMaker. Yes, you have everything in trial version. The questions from Tom Stefano concerning the license modules, please send get a quote request. We have a flexible licensing system, so everything is tailored for your particular case, and they will help you to configure the license for you, and they will send you a quote. I think you will like the price. Have you added an undo function? It would allow users to try things and yeah, okay, let me say, actually, we added not an undo but snapshots function, which are created automatically. You can like roll back your project to different states, and when you like press calculate button, the snapshot is automatically created, and in some other cases all the snapshots are also automatically created, so your work is preserved, and if something goes wrong you can always roll back and like return to the state of the project which you had before. They are available here. If you click on the project on top on the project tab, you can see snapshots. Okay, and here is also a snapshot manager which is showing you the screenshots and the operations and the operation statuses, so you can find whatever snapshot you want, and also you can pin the snapshot so it's not lost in the history. So try it. I think you will like it. Sorry, I was not showing you the screen. Let me show it again. Wait a sec. Okay, now you can see my screen. So here is the snapshot menu. Yes, you can load whatever snapshot you want. Sorry. And here you have a snapshot manager. Okay, you can check the screenshots and the operations, so you can find better your snapshot in the history. And here is the pin button, so you can pin your favorite snapshot so you don't lose it in the history. Okay, let me switch back and let's continue with questions. Can we also how to do this from scratch? You can see how to create projects from scratch. Of course, I could not do this during this demonstration because it would take some time, but please visit our website and you will, in the Learn section, you will see the lessons. There are not big amount of them by now, but we are working on adding more and more lessons, and these lessons are made specifically to guide you by hand, step by step, to create the projects from scratch, like from completely blank project until the end. Okay. Yeah, for the good question about for polishing, can you use force feedback? By now, the answer is no, because our this solution, ENCY Robot, is an offline solution, so it is not working directly with the equipment. So it's only working with a digital twin. But there is an option. You can use some embedded algorithms in your controller for feedback, like real-time correction. And we are also working on online robot programming software, but it's completely different topic. I will not tell you much details about it right now, but please keep in touch with us, because I believe in some time we will make a very big announcement concerning hybrid robot programming approach. That's all for the moment, so everything I can tell you now. Is there any competition for any ENCY robot programming? I think no, it's the best software for robot programming. Okay, next question. Do you have any examples of using disc cutting at an angle? Yes, please explore project library. We have a 6D disk tool operation, so we can cut, position the tool, the disk tool in whatever orientation you need. How we can account for tool wear? Only with the compensation. It's possible also. So, next question. Approximately how accurate is the time in the simulation versus the actual machine time to provide a price for example, welding? Good question. So in order to make accurate time, you need to define the feeds and speeds inside the project correctly. What I would like also to say that we are working, especially for additive manufacturing, this is critical. We are working on dynamic feeds. We have some already features in the. We already have some features for dynamic feeds in the non-planar slicing operation, which involve slowing down at around sharp angles, so it will make the estimate of the toolpath more precise, but also it's very critical for additive manufacturing, because according to the feeds and speeds, there is a material, how you say it, screw which is outputting the material, so we must also send commands to this equipment so that our material feed is aligned with the feed of with the working feed of the tool. So it's important. Okay, so the answer is we are working on it. In some cases it's really good, in some cases maybe not very precise. Try it yourself and tell us, maybe you give us the feedback and we will improve it if it's required. Why is it turning red sometimes? Do you need to correct the axis in the graph you showed before? So red is a bad situation, okay? Red means something is wrong, so there may be some collision. You can take care of it or you can ignore it if you want, but you are at least notified about this. Please take a look at the lessons and you will understand everything, I think, very fast. The question about Cura, custom machine setup, how to import the custom machine setup from Cura to the operation settings. Actually, it's another topic. Please, I'm Robert, who asked this question. Let me. I think I should answer you, we should answer you personally, okay? So please send us the request in the service desk and we will take care of this. Can we load our own post-processors? Very nice question. As I already said, all the algorithms and all the toolpath calculation and simulation and also post-processor are our proprietary developments. So of course, third-party post-processors will not work. Okay, but you can make your own post-processors, or you can use generic post-processors and customize them. We have post-processors for all robots which are supplied within the trial version. So you can customize even the post-processor in the trial version. We have lessons for post-processor customization. It's a very, very big topic. So, like, short answer is yes, you can load whatever post-processor you need, and you can customize it to make a precise ENCY code, which you will not need to make like additional changes with to run it on the robot. So you can export a ready-to-use control program for your robot with the post-processor. So you don't need any other like software or converter or whatever, or simulator, whatever, nothing. Okay, the question is for deburring with aerospace series, part series with minor dimension difference where 5-axis toolpaths are involved. Is it possible to reuse operations created for one part for other parts? Maybe yes. We must take a look at the parts, and then we can give you a reply. Probably you could send us a request. We will contact with you, and you will send us like a demo parts, and we will take a look. I think why not? Okay, yeah, concerning snapshot, yeah, it's great, but actually I agree with Steve. A simpler undo function for minimal changes like parameters would be super helpful. Yeah, and we know that, yes, in some areas we can still implement an undo. We have it, for example, in CAD module. We have it in some setup processes. We will work on it. Maybe we will implement in the inspector also. Is AI involved in suggesting improvements for toolpaths or only for project management? We are working on an AI assistant, I would say. Now it's like more an assistant, like a general assistant, but of course we have a plan to implement an AI for assisted project creation, but it's a completely different topic. I will not speak about it right now a lot. The only thing I can say, please follow our announcements, and I think you will see the AI related news quite soon. Would you know if other robot programming software offer collision avoidance or collision detection? I don't know, other software, maybe yes, maybe no. So why you need other software and you have ENCY Robot? Okay. XYZ correction of the ready program can you implement off regular license? I think yes, but maybe it's better that you send us an example and we can take a closer look on this. Maybe I don't understand very clearly what you need, so please send us contact us and we will see. Okay, so it's already 15 minutes after finish of the webinar, so we are a little bit out of timing. I would like to say to all of you, thank you for coming. So I try to answer the questions. If you will have more questions, please write them in the chat. We will answer them in the chat after the webinar. So for now, that's it. So thank you all for coming. We will finish our translation. Our stream now. So after the webinar, telling you again, so you can download 30 days trial without any limitations, install it on your PC and see all the projects I was showing you today and much more in the project library. Also, please feel free to send a get a quote request at encycam.com. If you are interested in purchasing of the software, we will be happy to help you. And also, if you need a specific topic covered in the webinar, if you are interested, please write it in the chat. We are reading all the feedback, and the next webinars will be planned according to your requests. Okay, so thank you all for coming. We are finishing the webinar, and see you